Hey cats, I just saw a video made by Vincent Schwenk on Instagram. Let's see it. He did it in Cinema 4D and Xparticles, and I decided to recreate it in Houdini, and I will show you how to set up this simple one. So let's start. Let's create a sphere. I will call it emitter. And let's change primitive type to polygon and increase frequency to 10. And in order to save our time and not build from scratch everything, let's make billowy smoke from the shelf tools. So select your emitter and click billowy smoke. Let's go level up, dive in emitter. Here we can see our source. And because we don't have velocity, let's do it. So let's plug a point velocity. And in the curl noise tab, let's activate curl noise. I made scale 3.5 and increased fill size to 5. Now we have velocity and we also rasterize it. You can see it here. Attributes, fuel CDN alpha we can delete because we don't need it. And let's see our velocity. You can visualize by turning display point trails, but we can see it. Now we can see it. Now let's turn it off and go to Pyro import. We can delete Pyro visualization, and we left now with our volumes. And also we can delete CD, fuel, heat, and 2 rest attributes. Sorry, rest. Now we have density, velocity, and temperature. And let's make it null out volume. Let's go outside. Go to emitter, and let's create from a sphere. Let's create points from volume. I made separation 0.05 and jitter scale 0.5. Let's plug it to pop network. And emission type will be all points, and we have to start only on the first frame. We have to set our emission only on the first frame, so let's type here $f equals to 1. So we starting only on first frame our simulation, and let's bring here our volumes. So let's make pop advect by volumes and bring here our volume. Field name is going to be velocity, and we have to set advection type to update velocity and set velocity blend to 1. Let's see what we have. Now we have advection, but you can see that that our simulation stops here, and this is because in our Autodep network we have this bounding box, and it's because of this node resize container. We have to uncheck max bounds, clamp to maximum. And now let's see what we have now. And now we have our advected particles by volume. So from this popnet, let's make VZB from particles. We have a big spheres. Let's decrease voxel size to 0.2 and point radius scale to 0.4. And also let's reduce minimum radius in voxels to 0. Let's add BDB reshape, and I used close with offset on 1.5, and also I used VDB smooth SDF, and I used here mean curvature flow with 4 iterations, and let's make convert to polygons, and now we have our polygons. Let's drop a null, call it out mesh for export, and let's also delete name attribute because we don't need it. So attribute delete, and let's delete primitive attributes. Let's delete the name. Okay. Now let's from pop network, let's also drop attribute delete because we have a lot of attributes here that we don't need in our final simulation. So also attribute delete, and I will delete everything, and also I will delete a point group, so group delete, and this is our particles that are ready for export also. So let's drop a null and call it out particles for export. Okay. Now let's go level up, and we can turn off emitter and pyro import and drop a new geo, and I will call it mesh. Drop object merge, and let's take our mesh for export and transform into this object. So now we have mesh for export. Okay, this is ready. And also let's drop another geo, call it particles for export. Let's drop also object merge and bring here our particles into this object. And we have to randomize particles scale. So let's make pscale attribute, one dimension, and let's make custom ramp. In order to visualize how our pscale looks, we can drop here sprite node, and we can see that our particles is too big. So let's decrease it. We can make here variations of how it can be looked in Cinema 4D. Okay. So we have also big spheres and also small spheres. Let's save it. Delete sprite node, and now we have two attributes, position and pscale, and also let's drop here another attribute randomize, and now we use CD, but with only two values. So two values. Probability of value B is going to be 0.3. Now we have also black and white particles that we will export to Cinema 4D. So drop here alembic rope alembic output, and let's cache our particles. I will cache it here, let's call it particles dot abc, and we using render frame range. And do we have particles here? Why I can see it? Okay, I can see it. Let's save to disk. Cache is completed. Now we can see our particles. And also let's go to mesh for export and make here also ROP Alembic output. And let's go to render frame range and also save mesh.abc. And let's also make save to disk. So our mesh also is cached, and now we have also mesh and particles ready for be exported to Cinema 4D. And I will see you in Cinema 4D in a couple of seconds. Now I'm in Cinema 4D, and you can see here it's my previous setup. It has a simple, let's fire render view and let's see what we have. It's a simple BG, so this is only a plane and DOM light, and let's delete it, our mesh and also our particles, and I will go through how to set up from the scratch. So let's bring particles, and we have to increase scale to 100. Okay, now we brought our particles. You can see that we have particles. Let's apply redshift tags object, redshift object, and save and choose a mode, optimize spheres, and you can see that we have our spheres. But now they are uniform. And if we go to syncing particles and in TP settings, you can see that I brought particles for export. This is our Alembic file from Houdini. This 01, it's from my previous setup, and here it's a new setup. So let's apply on syncing particles. Let's apply an expressor tag, and let's bring here 3 nodes. We have to bring get data, ppass, and set data. Okay, let's plug ppass to particles, to get data particles, and also to set data particles. And from get data, we will bring CD vector that we made in Houdini and pscale attribute. So these two attributes we created in Houdini. So let's start from pscale, and I plug pscale to scale. And in order to see if we have updated version, let's go to start and press play. And now we can see that we have another particles that have a different scale. How we can see it? Let's scale multiplier, set scale multiplier in redshift object to 10. And you can see that we have not only a big particles but also a small particles. You can watch it here. Let's go. You can see that we have small ones and big ones. Okay, so this is working. And also let's go to expressor tag and also bring CD attribute and plug it CD attribute to color. And let's see if we have something. Yes, we have now two types of color, black and white. Now let's bring also another mesh, another Lambic file that is going to be our mesh, and also scale is going to be 100. And now we can see also our exported mesh. And let's apply glass to our mesh. And in glass, what I did, it's from the previous setup, so it's going to be white, it doesn't matter. What I did here, I increased dispersion to something about 20. And you know what, let's make it from scratch, these materials. I will delete it, and also I will delete particles. I believe I will explain you what I did here because it's really simple. Let's drop a new redshift material and call it glass, and apply it to our exported mesh. Choose a preset glass, and let's decrease IR to 1.12, something about that, and let's increase dispersion to 20. Okay, now we can see that we have these nice colors here, and let's make transmittance color set to something purple. Yes, and maybe scatter coefficient, let's make it turquoise. No, it's let's increase too much. Let's make it absorption scale to 0.5, I think. Yeah, something about this. And particles, if I apply to particles for export, you can see, first of all, this scaled particles is too big. So let's decrease scale multiplier by 5. Yes, something about this. And particles, what I did here, I just brought color user data. Okay, and let us show you. Let's type color user data. Okay, now we have just a black note. If I in attribute name, if I apply TP data channel CD vector, now we have black and white colors, and I used these colors to blend as a blend color. What I did here, I brought incandescent material, and this is a simple temperature, simple material of temperature set to lowest one, and this one another, it's a blue, and I choose color dark blue. And to these materials I just plugged one to base color and another incandescent material I plugged to layer color, and used as used the color user data as blending mode. And that's what we have in the end. You can play it and hear our setup. So I hope this was helpful for you, and see you next time.